just say it?
Yeah, it's a microphone.
Okay. The last talk of the day for track 2 is GNOME Crosswords Year 3 by Jonathan Blandford.
I know the guy. All right, let's go ahead and get started. This talk was really going to be done with Federico and I. It was supposed to be a 40-minute talk, but in the interest of time, I'm just going to be giving it solo, and we tried to compress the talk. Federico will actually be giving the full talk as a keynote at LOS, so if you get a chance to go watch it there, you'll hopefully catch everything that we tried to get across. First, a little bit about me. I've been involved in GNOME for a very, very long time, since '97 in fact. First code I wrote for GNOME was our solitaire game, and I wrote that for fun. Since then I've been involved in a lot of different aspects of GNOME, some professionally and some on a personal basis. I've been on the board, I've been on the advisory board, I've been on an engineer, and I've managed GNOME engineers. But right now I'm back to writing games just for fun. So here's a quick agenda for this talk. I want to focus on 3 things. I want to go through what GNOME Crosswords is and what it is that we've built. I want to give a little background on the process of writing crosswords from scratch, as I imagine that's unfamiliar to most people. And time permitting, I want to cover some of the architectural decisions we made around the tools for writing crosswords. We used a very different architecture than is traditional, and I think the decisions we made might be interesting. So what is GNOME Crosswords? It's 2 separate programs. First, it's a standalone game that lets you solve crosswords for fun. And second, it's a separate editor that lets someone write and edit crosswords. I started this almost exactly 3 years ago. For my entire life, I've loved doing crosswords, and I wanted to try my hand at writing some. The pandemic was starting to wind down a little, and I was looking for a new hobby beyond baking sourdough, and this seemed like an interesting little project. Fast forward 3 years, it's not so little anymore. The code base is now pushing 50,000 lines of code. It's mostly in C with some Python, and we're rewriting portions of the core in Rust. We have translations in 4 languages, and I'd love to see more, so if you can help with this, I'd love to hear from you. And it's grown into a robust open source project. We've had 28 different contributors over time, and I especially appreciate those listed above who helped me maintain this project. On the implementation side, the code is split between an internal core library and the interface. The internal library, called libipuzz, lets you load, save, and especially manipulate crossword files. It supports the ipuzz file format natively, and we have some very basic support for implementing some other file formats as well. Since I'm sure most people here are unfamiliar with crossword file formats, the ipuzz spec is an open spec built on top of JSON. Most puzzle file formats are very undocumented and proprietary, so we chose this one. libipuzz is entirely internal at the moment, but in the medium term, I'd really like to support it publicly. There are plenty of simple puzzle loading libraries out there, but I haven't found a good one yet that supports manipulating crosswords like we do. We're in the middle of adding geometric introspection support to take advantage of all the language bindings and doc support, and I'd like to target a public release by the end of the year. We're also in the process of migrating libipuzz to Rust. I love and trust Emanuele a bunch for JSON glib, but we do way too much string and file manipulation in C for me to be really comfortable with it in the long run here. And I have Pranjal, a GSOC intern, doing a fabulous job on converting it to Rust right now. On the UI front, there's a lot of widgetry shared between the 2 programs, but the editor's probably about twice as big than the game in practice. Okay, it's enough talking. I'd love to give a brief tour of the game, and I'm not as brave as Martine, so rather than risk a demo, I took a bunch of screenshots of it in action. However, the best thing you can do is probably download it and try it yourself. That's much better than screenshots or demos. So, this is what you see when you first start the game. It's a very simple screen showing all the puzzle sets you have installed. If you select one, you get to a puzzle selection screen that looks like this. You either get a list of puzzles to play with or a thumbnail view of available crosswords. And selecting a puzzle will get you to the actual game. This is what it looks like when solving a crossword, and I imagine it's familiar to most people and probably pretty comfortable too. please note, this is sort of what we would call a standard crossword, sometimes called American-style crosswords, and I assume everyone here has tried one at least at some point in their life. You can tell it's a standard crossword puzzle by how dense the grid is and how terse the clues are. Oops, I think it went once too many. But beyond standard crosswords, we support a number of different crossword types and features. We support cryptic crosswords, which are also very popular, and most crosswords can be classified as either cryptic or standard. They're characterized by the sparser grid, so you can see fewer light squares there, complex cues, and the distinctive word breaks and punctuations that you can see between the cells. We support rebuses, which are crosswords with multiple letters in a cell, and barred crosswords, where you see a line between each cell rather than blocks. We support a variant called error words. These are more common in Europe and feature the clue in the block. They also tend to be non-symmetric. And we grew support for a puzzle variant called Philippines. These are mostly found in the Netherlands, actually, and it was a user-contributed feature. And finally, we support acrostic puzzles. These technically aren't crosswords, but are similar enough that it was fairly straightforward to add them. And I'd like to give a shout out to Tan Mei, who was a GSOC student last summer. He wrote this and has continued to work on acrostic support long after that program ended. Hopefully you guys can see that. Like all good modern GNOME apps, we have an adaptive layout. We work on both very large and very small screens. And finally, we have the ability to call out to a third-party crossword downloader to grab crosswords. So, how do you actually write a crossword? On the surface, it's really easy. You pick a clever theme to base your puzzle around. You then create a grid based on that theme, and then you write the clues. Of course, it's not actually that simple. The thing is, with standard crosswords, creating grids, especially creating grids manually, is really, really hard. On the other hand, writing good clues for cryptic crosswords is similarly tricky. Why is that? So, I'm going to introduce you to a fundamental rule of crosswords. Every cell needs at least two paths to its answer. Every cell needs at least two paths to its answer. If you've ever solved a crossword, this is a rule you've probably internalized without realizing it, and as a player, it's really annoying to run across a puzzle that breaks this rule. In fact, this rule is so important that crossword setters have the term unch to describe parts of the puzzle that break this rule. Unch is short for unchecked, and unches are to be avoided. So let's look at this in a little bit more detail. This is a standard crossword, and you can tell because it has this very distinctive grid here. It's very dense. There are a lot more letters on the grid than other puzzles. As you can see, every single cell has both an across clue and a down clue associated with it. That is our two paths to solving a cell. And we want to try and avoid this sort of pattern here in the lower right, where you have a light cell that only has one direction to fill it in. This dense grid is really important in practice, as standard crosswords have terse clues. So for this puzzle, let's look at one across. The clue for that is beneath, and it's 5 letters long. So in this instance, both the words under and below are possible words that can mean beneath. And the first time you read one across, you may not know which of those two fits there. It's not until we read one down and find a word that also starts with U that we can feel confident that under is the answer and not not below. And that's our two paths to filling the first cell. And hopefully that made some sense. When writing standard crosswords, you need this dense grid with both answers in both clues in both directions for each cell. And it's really, really hard to make a grid like this manually. There's a lot of trial and error involved, a lot of backtracking that goes on. You have to find words that fit. You have to add or remove blocks to make it work sometimes. And computers make it a lot easier. To aid in creating a grid like this, a number of tools are traditional and helpful. And we currently support the first two, at least a little on this list. Now I want to look at cryptic crosswords. That's the other common crossword type you run across. They are traditionally much sparser, and those would be filled with unches if you had traditional clues in them. However, cryptics are interesting because they use clues to provide redundancy, as every clue provides two paths to its answer, often a straight definition at the start or end of the clue and some wordplay. And it is possible to get unches in cryptic crosswords. If you have a run of 3 lights in a row, that's pretty frowned on. All right, so how do cryptic clues work in practice? I'm going to walk you through a couple of clues and their answers, and hopefully this will make some sense. First, we're going to look at 3 down. 3 down, if you can read here, is throttle. The clue for that is check the gas pedal, and the answer is throttle. And I'll give people a few seconds to see if they can see why. So this type of clue is called a double definition clue. And it's got 2 definitions for the word in the same thing. To throttle something can mean to check it. If you have like a flow of something, you throttle it, you check its progress. It's also a term for the gas pedal in a car. In this instance, we have 2 paths to the answer. I'm going to look at another clue to see if this can make sense and you get a sense of what cryptics are like. But we're going to look at 18 across, and the answer there is Lech Walesa. And the clue is leader from Harlech Wales appointed. And if you note that there's a 4,6 at the end of that clue, that shows it's a 2-word answer. The first is 4 letters and the second is 6. And if you actually see in the grid, there's a dark line between the answer here, if I can get my cell going, to indicate that there's a word break there. Anyway, give people a second to see if they can see why it is that. Well, here's the breakdown. Lech Walesa, of course, is a leader. He was leader of the Polish Solidarity movement and the first president of Poland. Great man. But why the second half? What's the second path to this answer? Well, it's in there. So it's literally from the word Harlech Wales appointed, and that gives you the second way to get to this answer. This is called a hidden word clue, and it's kind of puzzle you might run into if you're doing a cryptic. Don't worry if you didn't fully get these. They can be really confusing the first times you encounter them, but there's a lot of conventions you run into and they're a lot of fun. I put a link there to some explanations of the various kinds of cryptic clues you might run across. And not quite sure what happened there, but I'll say that writing cryptics is an art form. You need the same tools to create the grid as standard puzzles, but it's a lot easier to find words that fit. Instead, there are a lot of different tools that setters use when running clues. We have a few. We have anagrams, and Protham was our GSOC student last year. Ignore all those extra P's. And he worked on that support, and we also support alternations. But this is a really ripe area of exploration. So now that you have a little idea of what the process of writing crosswords is like, I'm going to do a quick visual tour of what the editor looks like. When you start the editor, you get an initial greeter to pick the puzzle type that you're creating, along with some possible templates. Selecting templates gets you to a screen to edit the grid. I've put in a pre-filled grid here just to show what the statistics look like, but normally it would start blank, of course. And you can see across the top the various modes for editing. You've got grid, then clue, and then metadata. We have a word suggestion tool that will offer words that possibly fit in the grid in a location. This is useful for filling things out. And we have a rudimentary autofill tool. This is fast enough to be able to suggest letters for fairly large sections of the puzzle. It's a little too slow to solve the full puzzle today, but I'd like to make that faster. Once you've created your grid, you need to write your clues. For standard puzzles, it's a little bit easier. It's often definitional, but for cryptic clues, I hope as you got a sense, there's a lot more involved and there's a lot more information here. You'll notice that we have the start of some additional cryptic writing tools at the bottom. We have the anagram, the odds and the evens. These are just tools to try and spur imagination when writing a cryptic. And finally, like all good file formats, it has metadata associated with it. The last part of creating a puzzle is setting that. I know there was a lot there, but I'm hoping people got a good sense of both the problem space and the tools that we use to create crosswords. And I'm going to spend the rest of this talk covering how we wrote the editor. So I want to start by highlighting a few things that make writing the crossword editor tricky. First off, rendering crosswords is surprisingly hard. They render a little bit like fonts. They don't scale linearly as grid and cell positions need pixel alignment. They also fight quite heavily with GTK sizing assumptions. Second, we can't put too many assumptions into the code base. Good puzzles follow conventions, but a lot of great puzzles break them, and we'd like to support some corner cases. Third, as I mentioned, there's a lot of specialized tools to avoid those unches. Each one comes with its own unique set of challenges, and honestly, it could do a whole talk about of its own just on writing these. And then finally, small edits can lead to big changes in the puzzle. I want to dive into the last one in a little bit more detail and show an example because it really affects the architecture of the editor. And I'd like you to keep this example in mind because we'll refer to it for the rest of the talk. Consider a simple grid that the setter is writing. Imagine that they press the pound key or hash key, which will change the cell at a cursor to be a block. When we make that change to the puzzle, we end up with something like this. But that puzzle is all wrong. We now start at 2 across and 2 down, which is broken. No crossword should work like that. We broke the symmetry of the puzzle. We broke any enumerations that existed. So if we tried to correct that, we end up with something that looks a bit more like this. This is probably what we want to have happen. But even that has led to some pretty big changes. The clue for 1 across is now refers to a word that no longer exists, and the clue for 10 across is now the clue for 9 across. So the renumbering sort of changed the way that the clues set up, and clues either disappeared or reappeared. And I hope you start to get a sense of how complex sort of working with crosswords can be. And that leads me to the requirements that we have for this editor. Given how complex operations can be, our biggest focus when writing this tool was to keep the code base as simple as possible to reason about. This is a hobby, and that's true for all the contributors I have as well, and we need straightforward rules for when engaging with the code base and for thinking about the problem space. Along the same lines, we really want all our operations to be testable. We've done a decent job about writing tests for the core, and that has saved our bacon so many times it's not funny. It's very easy to make a change in one area and have unexpected changes in other areas of the program, and having a comprehensive and robust test suite helps mitigate that. As our last example highlighted, we want to make undo and redo core to the application. If a small change can delete whole clues, we need to be able to undo those operations. So we designed this from the beginning to be very, very undo friendly. It's not easy to tack that on, or it wouldn't have been easy to tack it on after the fact. And finally, we need specialized tools to avoid those unches, and they need to be fast. They really are about trying a bunch of different things, not waiting for the answers to come up. When I started doing this application, I had planned on doing a somewhat traditional MVC-style architecture. But after a long chat with Federico, we decided to experiment with unidirectional data flow architecture. This approach is a lot more common in web frameworks such as React and Angular, but is a lot less common in desktop applications due to our in-process nature. However, it has some really nice properties. Namely, it's highly testable and very, very predictable. This architecture is based on an action model view approach where UI events happen in a browser and callbacks don't modify the model directly. They generate actions instead, which can be represented as values, aka you can serialize it. We then update the model based on the actions, and the view is constructed from the updated model. This approach is really good for the web, as control flows from the browser, where the user interacts with it, to the server, where the model is updated, and back to the browser, with values going over the network. But that's not how desktop apps are written, though. So we made some adjustments to translate this to how you'd write something with GTK. So how did we do it? We kind of have 4 fairly simple rules to keep in mind while writing the crossword. First off, all state for the app is kept within a struct. That struct is just data and can be fully copied and serialized. Second, widgets are stateless and commutative, and I'll define what this means shortly. Third, all control flow is centralized in a top-down dispatch model. And finally, we do our best to have each source file as simple as possible and concentrate our complexity in only a few areas of the code base. So it's going to go into a little bit of detail. Hopefully have some time for questions at the end. But let's look at our earlier example. If we have the puzzle in a starting state and the user presses that pound character, the editor state just changes to a new state. Let's call it state 2. We can then send that state out to all the widgets that can be displayed. And the code for that state is really simple there. But the thing to note is that when we create state 2, we make a complete full copy of everything included in the crossword. And that means that the 2 states are both valid and they both could be used for display. And all state is kept in a single struct. For the game, we have a very small struct. It's grid state, you can see the whole thing there. It's just the crossword file and a little bit of display info. On the other hand, the editor has some 20 different members and 4 distinct grid states for its state structure. But the important thing to know is that we make a full copy of it. That means a full copy of the crossword. We duplicate it, we don't ref count it. Everything there is a value, and while we don't serialize it right now, everything could be serialized just to file and reconstituted. It's just basically a number at the end of the day. One rule of thumb we've had for mutating crosswords is we do it as a 2-step process. We make all the changes we want to the puzzle and then call specialized functions for fixing the puzzle to follow convention afterward. So in this example, we set the cell type, we change it to a block, and then fix the symmetry, fix the numbering, fix the clues, et cetera, and that significantly simplifies the mutation code. And finally, once we have our new state, we push it onto an undo redo stack, and that means that undo and redo is basically as simple as picking an older state and rendering it. The undo stack also keeps the pointer to the current active state, but it can move up and down the stack and just make a new state available. Let's talk about widgets for point 2. We have over 50 custom widgets within the game, so setting some rules for them was important. I said that widgets are stateless and commutative. When I said that, I mean that they have anti-hysteresis properties, which means that when set to a given state, they behave and render the exact same way independent of the path that they took to get to that state. That's really important because it means that there's no game state implicitly within any widget. I got this term from a great blog post that Colin Walters wrote a couple years back, where he's talking about OS tree, OS images having this property. It's a bit of a mouthful, so we're going with commutative, but a better term would be suggested. And we do this by having a single way of setting value on the state. Every widget just has one way of state going in. It's got an update function, and one way of information coming out. It's got a changed function, and optionally it has a value with that changed information if it's relevant to the widget. They store just enough information to render and cache to themselves. They never ever change the state of the application, and there's 0 lateral signal connections or signal connections to data, although we do hierarchical for propagation. I'm going to skip this one in the interest of time and go to point 3, which is control is centralized in a top-down dispatch model. As you can see, all widgets sort of go up through one single object that exists. It gets all the requests in, it decides what to do with it, it updates the puzzle, fixes it, and then dispatches it out to the widgets as an update. Widgets themselves will never touch any data. And finally, just a quick call out for this. We try to put all the complexity of a given area into one file, rather distribute it across the application. So we have 3 or 4 big files, one that handles all the crosswords, one that handles all the dispatch and all the callbacks, one that handles all the file operation, and one that does word lookups. And what that's meant is that data structures and widgets in general are actually very simple. They do one thing, they render themselves, and it's very possible to engage with them without remembering any of the information about that. When you have to go into the crossword behavior, you kind of have to refresh yourself, but it's all in one place, and it's very, very well documented. All right, I've got -2 minutes for questions, so I guess I'll take them in the hallway, or if people want to try now, we can do something.
Yeah, I think we're out of time. Thank you so much, Jonathan. I didn't realize crosswords were that complex. That's really good. So next up in 5 minutes at 3:45, there's a keynote from Ryan Sipes about Thunderbird, the death and rebirth of an OSS project in the main hall. Thanks, everyone.